Trains are a marvel of engineering, effortlessly gliding across vast distances.
How exactly does a train, a rigid assembled wheels fixed to axles, unlike a car with steerable wheels, a train's wheels are rigidly fixed to an axle.
Today, we're diving deep to unravel the ingenious engineering behind the railway switch. How do trains change track? Let's find out.
Unlike road vehicles that can simply steer, trains operate on a fundamentally different principle. They are guided by the track.
The secret lies in the wheel's flange, a raised edge on the inner side of the wheel. This flange doesn't bear the train's weight.
This rigid guidance means that train wheels are always fixed in relation to their axle. They cannot turn independently.
Unlike an automobile, where a steering wheel allows the driver to actively change direction by angling the wheels.
This brings us to a critical question. If trains cannot steer, how do they navigate between different routes?
A track switch consists of several critical components: the point blades, the stock rails, the frog, and the actuation unit.
The point blades are tapered, movable rails that guide the train wheels from one track to another. Alongside them are the stock rails, which are the main fixed rails forming the continuous path for the train.
Crucially, the frog, or common crossing, is the heart of the switch, where the two rail lines intersect and cross each other.
Connecting these point blades are the tie rods, crucial for maintaining their precise distance and synchronized movement. The switch motor, or actuator, is the automated powerhouse responsible for moving the point blades, precisely guiding trains to their intended tracks.
A closer look at the point blade tip reveals its critical tapered design, engineered for a seamless transition as the train wheel. Understanding the rail's cross-section is fundal head bears the wheel's load. To differentiate functional groups, we can apply technical color coding. Movable elements, like the highlighted central to a railway switch's function, are the point blades, precisely engineered movable sections of rail that guide the train wheels. These blades are interconnected by tie rods, a crucial internal assembly that ensures synchronized movement and structural integrity. Upon activation, the entire assembly of point blades and tie rods precisely shifts, changing the path for the train's wheels. When the blades are configured for a diverging route, as a train wheel approaches from the diverging route, its flange is designed to engage with this opening. The wheel flange gently engages the open point blade, which acts as the initial guide to direct the train onto its intended diverging path. These blades precisely guide the wheel flange, preventing any deviation and ensuring a controlled transition onto the new track.
Even with precise guidance, this interaction generates a small amount of friction, visibly demonstrating the forces at play as the wheel is steered.
The illuminated inner surface of the point blade visually confirms its active role in safely diverting the train. Once the train has passed, the point blades return to their closed position, forming a precise and secure fit. Now, let's turn our attention to the frog, a critical component that allows train wheels to smoothly transition across. A cross-section reveals the meticulous engineering of the frog, designed to guide the wheel's flange safely across the rail intersection.
Observe closely as the train wheel approaches and then passes over the frog. The design allows the wheel's tread to bear the load.
As depicted by these highlighted paths, the wheel's flange traverses a carefully engineered gap in the frog. This critical flangeway gap at the frog is precisely engineered to a standard of 45 millimeters. Beyond the precise gap, critical safety features ensure the switch is correctly set and locked. These include As the point blades begin to shift, the attached detector rods mirror this movement. This critical leverage and transmission With the blade's position verified, the final, crucial safety step is initiated. The locking bars.
This X-ray view underscores the robust internal design, showcasing how precisely the locking bars.
Railway safety is paramount, and the integration of switch mechanisms with signaling systems forms the backbone of secure rail operations.
Each switch mechanism is intricately linked to a centralized signal box, ensuring real-time communication of its position and status. This immediate feedback is critical. A red signal for danger, yellow for caution, and green for clear passage.
This interlocking principle prevents conflicting movements, ensuring a signal cannot clear a route.
This intricate network relies on constant communication, with data flowing from every switch to a central signal box.
When a switch is correctly set and locked, its status is relayed to the signaling system, which then clears the corresponding. This real-life example demonstrates the precise coordination. The switch is set, validated, and only then.
However, a misaligned or incorrectly detected switch triggers an immediate red signal, forcing any approaching train to
With the switch now correctly aligned and detected, the signal clears, allowing the train to safely. Beyond simple turnouts, railway networks employ specialized designs. One such example. Building on this complexity, the double slip switch offers even greater flexibility, permitting trains to switch tracks. For tracks running side by side, the crossover switch is essential, enabling trains to transfer efficiently from one parallel.
Modern railway engineering also introduces high-speed turnouts, designed with longer curves and precise mechanisms to allow.
From simple turnouts to complex slip switches, crossovers, and high-speed configurations, the vast array. The precision involved in ensuring these massive vehicles transition flawlessly is a testament to ingenious engineering.
At its core, the switch relies on several critical components: the point blades that guide the wheels.
This intricate dance of mechanics ensures that, in the real world, trains like this one can safely and efficiently change their course. A critical operation performed countless times a day, smoothly directing rail traffic and maintaining the integrity of the network. From complex junction line, the railroad remains a cornerstone of modern transportation.